So I don't want to bore you with my career path, though there is a story in it. Bear with me. So I was already introduced to have been worked in lots of different companies, but there is one which I actually want to point out. I worked 3 years in Exabeam, and Exabeam back then was like the pioneer of machine learning-based threat detection. And the takeaway I took from these 3 years I spent there is it is an important piece in the whole puzzle of threat detection, but it is not the ultimate solution. So today we're still talking about crafting detections in certain languages. There are still a lot of human activity in it, even though, and I don't want to downplay Exabeam. It is a great solution, but it is not the universal answer to everything. So that's what my takeaway from that. Also, looking at all these certifications here, I've never been one of those who want to collect tons of certifications. But last year, actually, I looked at the MITRE ATT&CK Defender certifications. I'm not affiliated to MITRE, but I can highly recommend these. So yeah, that's why I've put them up here. Good. So let's talk about what the challenge is. And I will talk briefly about Sigma, RootA, and the open source initiatives to support all of these. And now it goes backwards. I don't understand this. Yeah, okay, good. So what's the challenge? Who of you is a detection engineer? Okay, at least a few. Okay, those of you who are familiar with detection engineering, you know this challenge, right? So there are tons of different platforms. We have SIEMs, we have data lakes, we have EDRs. Each of these have their own query language. Each of these have their own detection language. So these are just a few examples, right? So I assume many of you already developed detections in Custo for Sentinel, or SPL and Splunk, or AQL and Curator, or KQL, EQL, ESQL, Lucene. You know all of these languages, right? Chronicle. Now we have Amazon Athena coming around. So lots of different languages. And of course, the detection engineer is usually in a hurry, right? So there is something new coming around. You need to build a detection, you need to document it. And of course, you want to benefit from the native capabilities of your platform. So of course, you write the detection in Custo, right? But then how do you share these? I mean, of course, we want to share across different companies, different organizations. But even I have seen companies like service providers who have a different SIEM internally than they use for their managed service. And then they have an EDR, and then they have a data lake. So even within a single company, it is already hard to share detection code across all of these different platforms, right? So what is the solution to that? And now I'm again going to the wrong direction here. So I assume everyone knows Sigma. Who knows Sigma? Oh, come on, more. Only so few know what Sigma is? Okay, good. So Sigma has been invented in 2016 as the meta language for threat detection. And it is a great solution. It really revolutionized how we can create detections across many different platforms. It actually is for logs. So it's maybe you could consider it like Yara for logs, for example, right? So so you can actually describe any TTP in Sigma. There are huge repositories out there with Sigma rules. And it is designed to be like the common denominator across lots of different platforms. It is good to craft atomic detections, but it has always been very limited in crafting complex use cases. Though, correcting myself here a little bit, beginning of this year, the Sigma project released a version 2.0, which incorporates something like correlation capabilities, which has always been a drawback of Sigma. So there is now more function in it to craft complex use cases, but it's brand new and it's still limited. And Yeah, but that's by design. It has been designed to be simple and to be a common denominator across all of these platforms. But with everything fantastic in this world, it has its downsides, right? Nothing is perfect. So what are the downsides? So let's have a look at these. So from a detection engineering's point of view, it is actually a fantastic language if you want to build something top-down for sharing. So if you have sharing in mind from day one, and you want to craft a detection which you want to share with the community, you would build it in Sigma, which is fantastic, right? But if you are a detection engineer who has not enough time for your day-to-day work, you will probably start crafting your detection in SPL, KQL, Custo, whatever you are working with, because it's just nearer to your work and it has lots of different functions you want to use. So there are aggregation functions, there are correlation functions, whatever. I mean, all these platforms have platform-specific functionality, which of course the detection engineer wants to make use of, which are very hard to transition over into a language like Sigma. So if you don't start with sharing in mind from the beginning, then you run quickly into these limitations. From the backend developers viewpoint, the development of the Sigma backends have got more complex as Sigma actually switched from they coded Sigma to PySigma, which modularized the whole concept and made it more flexible. But for those developers who develop these backends, it got much more complex. And so yeah, that might also be a drawback here. So let's see how we can overcome these limitations. So what I want to introduce you to is RootA. So what is RootA? RootA is the evolution. It's not there to replace Sigma. It is there to complement Sigma and actually to step in there where Sigma has its limitations. It is, yes, an open source language for detection and response. But the main goal for RootA is to actually accelerate collaboration between detection engineers who are not, in its first place, developing detections in Sigma. There is another use case, and that is especially looking for like service providers who onboard customers who had been on a different SIEM before. Like I would assume some of you work for service providers and you know that problem, right? You run your service on Sentinel, for example. Your customer has been running Splunk so far. They have tons of custom content. They want you to migrate that content over to your Sentinel platform. How do you do it, right? So that's another use case. So you can't just go backwards and say, okay, translate Splunk to Sigma, because it doesn't. Sigma can't just cover all these Splunk-specific functionalities. So it's the second use case, right? So it is about sharing. How can I share my detection without developing in Sigma? How can I translate from one platform to another? And RootA is here to actually answer that question. How does it do it? So RootA was built with extensive native metadata in mind. So it has MITRE tag at core, not just a few tags. It is actually a fundamental piece of it. It has the threat actor timeline included and threat intelligence information included. In addition to the required log sources and services, which Sigma also has, it also includes like audit information and instructions. How do I need to configure my system in order to get the right events, right? So if I'm missing the right events, which policies do I need to deploy in order to generate the events I need, which is often a fundamental missing part. It has a very high flexibility because it is in container format. So it has just a structure of metadata, and then it contains a query and a query descriptor, and the query could potentially be any language, though it, of course, in its first iteration supports a handful like Splunk, Sentinel, so a few source languages from which it can translate to any other language. Yeah, but it has the potential to cover more. It has native correlation, aggregation, function mapping. So what we do is we build mapping tables between functions from Splunk to Sentinel, from Sentinel to Splunk, from Curator to Splunk, which sounds complex, but we found a method of doing that pretty efficiently. So actually, if you use those native functions, we try to translate them, and that is a big differentiator to Sigma. It natively supports OCSF taxonomy. And something we have always been thinking about for the future is how can we embed response as code? I mean, we've been talking about detection as code for years now, but what about response as code? How can we create atomic response code pieces and make them generic? And this is something we also want to embed into RootA, but this is for the future. There are already certain open source tools which include support for RootA. So if you want to play with it, if you want to look at it, SOCPRIME's always been very open in the open source space. We've always had certain tools which we made open source. And I think the most popular one is Uncoder.io, which has been around for years now, which is basically, in the past, it's been a front end to translate Sigma code into the native language. Meanwhile, it supports more. It supports also RootA as a source. It does also create, for example, queries from IOCs. So you can actually plug in any type of IOC, like a PDF, like an HTML page, any list in that Uncoder thing here, which is open source, right? You just Google Uncoder.io, and it outputs you a very nice crafted query for the platform of your choice. And yeah, that already embeds support for RootA. Another open source initiative, which is about to be RootA enabled, is Prime Hunt, which is, I think, less popular, though I think it is something everyone should look at who works with the logs on a day-to-day basis. The Prime Hunt is actually a browser plugin, and it plugs into the various search interfaces of the most common SIEM or EDR tools. So it plugs into Splunk, it plugs into Sentinel, into Defender, into Amazon, and various other platforms. And it has certain functionality in there to aggregate, for example, drill down, and so on. And it just lives in your browser. It's open source. You find it in a browser store, and that also will support sharing a query to the community through RootA. So if you craft a query in Splunk, for example, or in Sentinel, and you find this query is so useful, you want to share it with your community, you will find a button in here. It will generate a RootA construct around it. So it will craft the metadata around it, gives you the opportunity to add a few meta items, and you can just click share and upload it to the community, which is, I think, accelerating sharing so much more than just posting a Sigma code somewhere on a GitHub, which you need to do manually, and you need to craft it. And yeah, that's the initiative. I hope we'll contribute to that, to the community a lot. And with that, before I open up to questions, we have a small fun challenge. Anyone has an idea where the name RootA comes from? No? So look at the logo. Maybe that is a small indicator. Oh, okay, good. So, okay, so for those who know SOCPRIME, you know that we have Ukraine history, and the RootA comes actually from Chernobyl RootA, which is the red roux in Ukraine, which is a symbol for love. And we thought, okay, love is something about collaboration and sharing, and that's why there is, of course, some parallel here to sharing, security, information sharing, detections, and this is how the name came up to be.